Welcome back to The Explainer. Today we're diving into a technology that is literally changing how we build, well, pretty much everything, from cars to entire cities. It's called a digital twin, and it's completely reshaping the future of innovation.
Okay, before we get into the good stuff, do us a quick favor. If you're getting value out of these explainers, hitting that like button and subscribing really helps us out. It lets us keep breaking down all the cool tech that's shaping our world. Thanks a bunch.
So here's a question every single innovator faces, right? Does it matter if you're in a garage startup or a giant corporation? How do you bring a new idea to life without completely breaking the bank? It's this endless cycle of build, test, fail, repeat, and it's super expensive. But what if? What if you could skip the most painful, costly parts of that whole journey?
Well, that is exactly where this new way of thinking comes in. It's all powered by something called a digital twin. And honestly, it's like having a crystal ball for your product, letting you see exactly how it's going to perform long before you ever tighten a single screw. Okay, think about it like this. Let's say you're designing a new electric car. The old way? You build a super expensive prototype, you ship it somewhere freezing, and you see what happens. The new way? You just drop a virtual model into a simulated Arctic blizzard. Poof! You get to see how the battery holds up in seconds. See the difference? We're swapping out all that expensive guesswork for hard, predictive data.
So what is a digital twin, really? It's so easy to just think of it as, a fancy 3D model. But it's so much more than that. It's not just a picture, it's more like a living, breathing, digital copy of a real thing.
Yeah, a virtual clone, that's the perfect way to put it. And it's not just about what it looks like, it's about what it does. This clone is built to act and react just like the real thing would out in the wild, with all the chaos and unpredictability that comes with it.
And that's what makes it alive. The data. It's not a static, dead model. It's constantly pulling in information from all over the place. We're talking real-world variables like temperature, pressure, heck, even how a person might use it. It processes all of that at once to give you this incredibly accurate, always updating picture of what's happening. Okay, this is a super important point. Because you might be thinking, hang on, we've had computer simulations for ages, right? What's the big deal here? And you're right. But the difference is, it's a giant leap from just testing one little thing to understanding the whole system. So look, a traditional simulation might tell you, can this one gear handle this specific amount of pressure? And that's it. A digital twin, on the other hand, shows you how that same gear behaves when the temperature suddenly drops. The whole system is chugging at full capacity, and it's being handled by someone who's maybe a little clumsy. It's about how everything connects and interacts, not just one isolated test.
And this, for me, is where it gets really cool. You get to ask all these what-if questions that will be way too dangerous or just ridiculously expensive to test in the real world. Like, what happens if a jet engine sucks in a bird during a massive thunderstorm? Or what if a crazy solar flare hits the power grid? With a digital twin, you can run those insane scenarios again and again and again, totally safely and for a fraction of the cost.
Okay, so how does this actually change things on the ground? From that first spark of an idea to the day you launch a product. Let's look at what this really does for the development process. This quote right here really nails the fundamental shift. For so long, engineering has been about reacting to problems. You build it, it breaks, you figure out why. Digital twins let you flip that completely. You become proactive. You find all the weak spots and design flaws in the virtual world before they become huge, expensive, real-world headaches. So the whole development cycle just gets smarter. Teams can play around with different materials virtually, run thousands of simulations while they sleep, and then, when it's time to build, they can commit to a design knowing, with data, that it's the best one. This means you can launch with way more confidence and a lot fewer uh-oh moments later on.
And look, this isn't just a neat idea. The numbers are real. We're talking about chopping development time down, slashing R&D budgets, and doing way fewer of those frustrating design revisions. It even helps get everyone on the same page, from marketing to engineering, because for the first time, everyone's looking at the exact same data-backed model.
But hold on, because the true power of this tech doesn't even stop with just one product. That's just the beginning. The really mind-blowing stuff happens when you start to scale it up and look at the whole system.
So instead of just a single car part, you could create a digital twin of the entire factory that makes the car. You could spot bottlenecks before they happen. Or go even bigger, model your entire global supply chain to see how it would handle a major disruption, like a port shutting down or a sudden spike in demand. We're talking about simulating the entire world a product lives in.
And once you can do that, The questions you can answer get so much bigger. Hey, if we switch to this lighter material, what does that actually do to our shipping costs 6 months from now? A digital twin connects those dots, showing you how a small design choice can send ripples through your entire operation.
So what's the bottom line here? It's really all about making smarter decisions and lowering risk. Every single virtual test, every what-if scenario you run, that's a real-world failure you just avoided. It's a game changer.
And that leaves us with a really exciting thought, doesn't it? If we get to a point where we can perfectly and instantly test any idea in the virtual world without risk, what's the next huge problem we're going to solve? We're talking about things that seem impossible today. It's an exciting future to think about. Thanks so much for watching.